you want to learn about linear systems?
I'm Ben Carbo.
I'm Eva Long.
And I'm Jonathan Santucci. So what is a linear system?
A linear system is when you solve two equations to find the intersection of two lines.
What does a linear system represent? Well, we could think of it as a map where we're looking at Beacon Street and Charles Street in Boston. And a linear system could be used to figure out where two streets intersect. So any of these smaller streets on the map.
So where might you see a linear system? Well, on any coordinate plane with two non-parallel lines.
There are three ways to solve a linear system. The first way is with matrices, known as Cramer's method, and there's also substitution and elimination.
One way to solve linear systems is by using matrices. What are matrices? Matrices are a way of organizing data or sets or arrangements of numbers. In the case of this solving for system of equations, we will be arranging them by column. So the x will always be over the x values, y's over the y values, and the constant over the constant value. Cramer's rule requires that we find three determinants: determinant of x, and determinant of y. What I'm doing right now on the board is I'm setting up determinant for this set of equations. We're taking the coefficients from the x and the coefficients from the y in the two equations. We're going to cross multiply and then subtract. So 2 times 10 minus 3 times 7 is -1. That is the determinant of the two equations. Next, I'm setting up determinant of x, in which case we are going to take the constants of the two equations, put that in the place of x, keep the y's. Do the cross multiplication and subtract again. We get determinant of x is 54. Determinant of y, we're going to reverse the process from determinant x. We're going to keep the constants from the x, and for the y, we're going to use the constants of the equation, in which case we get -38. To find the actual point of intersection, we need to take determinant x that we solved before divided by the determinant of the two equations, in which case we get -54. To find the y coordinate, we need to take determinant y divided by the determinant of the two equations, in which case we get 38. So the point of intersection between these two lines is -54, 38.
In this video, I am doing an example of substitution. First, what I did was solve for my y, and then I plugged that answer back into the next equation so that I would have an equation that just had x's in it. By doing that, I could solve this equation so I could have my x answer. And once I had my x answer, as you can see right here, I can then plug that x back into that first equation of 2x plus 3y equals 6, and I can solve for my y. So in this one right here, I have only a y variable. And then my answers here, it gives me one x answer and one y answer, and these two are going to be the coordinates of my intersection.
Another way to solve a system of equations is by elimination. First off, you have to multiply the first equation and the second equation by a constant to get rid of one of the variables. So in this case, we're getting rid of the x variable. So we multiply the top by -7 and the bottom by 2, and that crosses out. So we get -1y equals -38, and then y equals 38. That's our y coordinate. And we do the same thing for the y. We multiply the top by -10 and the bottom by 3, and we get -20x minus 30y equals -60, and 21x plus 30y equals 6, which goes to 1x equals -54. And that's our point. And the coordinate for intersection is -54 and 38.
Two parallel lines will have no solution due to the fact that they have the same slope, and two lines that intersect will have one solution because they have different slopes.
When solving a linear system algebraically, we are trying to find an answer for our x that it makes both equations true, and an answer for our y that makes both equations true.
The x's that make both equations true and the y's that make both equations true graphically represent the point of intersection.
Right now we're entering the equations of the two lines of the system in point slope form. After, we're going to press the graph button and the two lines are going to graph. And this is graphically representing what we solved in algebra, because in algebra we found the point of intersection, and this is graphing that point. After, we're going to press second, then trace, then 5 for intersect, and press the enter button until you get the word intersection.